Okay, still working on experimental design, and we're going to be talking about the randomized block design here, and we're on page 34 and 35 of the note spiral. And so here we're going to start off with a block design. Now notice I also have random allocation, so you will always have random allocation somewhere in the experiment, because remember, to be an experiment you have to randomly assign treatments. And the things that you block on are the things that have the largest impact on the study. So we block first, then we random assign. And it's really important that we notice this. We always block first, then the random assignment follows. So here I have a blocking variable, and it could be gender, where group 1 might be females and group 2 might be males. Then I'm going to randomly assign to treatments, and it could be the new treatment, the new drug, the old drug, and the placebo. Of course, it could be in any order. So this would be essentially females, new drug, females, old drug, females receiving the placebo. Here would be males, new drug, males receiving the old drug, males receiving the placebo. And at the end, we would compare whatever results are. The results you're comparing are your response variables. Now, in this case, we have two explanatory variables. We have the treatment variable, and then we also have the group that you were blocked into. So the gender variable in this case, as we called it, has two levels, female and male. And then we have three drug levels, the new drug, old drug, and the placebo. And if we have the two levels times the three levels, we find out that we have 6 treatment groups. So in this case, we have two variables, the gender and then the drug. And those are the two explanatory variables. And then we have the response variable at the end. All right, so a more complex one, if we look down, we have the multivariable design. And here I'm blocking on more than one variable. All right, so perhaps I'm blocking by gender. And by the way, if gender is one of the things that you're blocking on, and it's typically something we do block on because we do believe that there are differences between females and males in many cases. So if gender is something you're blocking on, block on it first, even if you don't consider it the most important variable. It just makes things easier. So block on gender first. So perhaps I block on gender and I have female and male. Then perhaps I block on an exercise program, an age program. So over 40, under 40, and then I have my drug treatments, which are randomly assigned. Once again, I'm randomly assigning treatments within the blocks. So the blocks come first, then the random assignment. So here I have 3 variables. The first variable being gender. The second variable we said was age. The third explanatory variable in this case would be the drug treatment. And then we'd have our response variable, whatever it was that we're comparing at the end. So if we went 2 times the 2 here, the 2 for the gender, times 2 for the age, times 3 for the number of drug treatments, 2 times 2 is 4, times 3 is 12, when we see that we have 12 different treatment groups for this particular experiment, whatever it is. So moving on to a randomized block design, high cholesterol, and this is page 35, 2000, question number 5. High cholesterol level in people can be reduced by exercise or by drug treatment. A pharmaceutical company has developed a new cholesterol-reducing drug. Researchers would like to compare its effects to the effects of the cholesterol-reducing drug that is currently available on the market. So we have a new drug and an old drug. And it says volunteers who have a history of high cholesterol and who are currently not on medication will be recruited to participate in the study. Explain how you would carry out a completely randomized experiment for the study. Now they said completely randomized. So that means I'm going to put everybody in a hat and mix. And that's what I said here. Place the names of the volunteers in a hat and mix, draw 50% of the names and assign to the old cholesterol drug. The remaining 50% is assigned to the new cholesterol drug. I use 50% instead of a specific number because they didn't tell me how many people were in the study. So half gets this and half gets that. After an appropriate time, compare the cholesterol levels between the two groups. So here, this right here, the cholesterol level is my response variable between the two groups to determine which drug has been successful in lowering cholesterol the most, because that's what we're interested in. Once again, we discussed random assignment, which we did when we said we draw 50% of the names. Then we said our treatments. So we have one explanatory variable, which is a drug type, which had two levels, the new drug and the old drug. And at the end of time, our response variable is cholesterol level, which we compare. So describe an experimental design that would improve by incorporating blocking. Once again, block on the variable that you believe will have the greatest impact on the study. You might have chosen gender. You might have chosen age. You might have chosen overall health. I happen to choose body mass index just because I think it's personally upsetting 3 letters to me. So block based on BMI, because those with a low BMI may respond differently than those with a high BMI. Randomly assign subjects within each block to the different drugs, so that half of those in the low BMI group are assigned to the old drug and the remaining half are assigned to the new drug. So basically, I'm blocking, and I have 2 groups, one explanatory variable that's tied to BMI, and you either have a low BMI or a high BMI, and you get placed in your group. All right? Then I need to explain how this is done. This can be achieved by placing the names of those in a low BMI group in a bin and mixing. The first 50% would be assigned to the new drug, and the remaining 50% would be to the current medication. So I've moved from blocking to the allocation of the drugs. Remember, you always have to allocate. So there's always going to be random assignment, even when you're blocking. So if you block first, then you randomly allocate. So those with low BMI into a group and mixing, the first 50% would be the new drug, and the remaining 50% would be assigned to the current medication. So you have low BMI with new drug and low BMI with the current medication. And then we're going to repeat the same thing for those with high BMI. So those in a high BMI group will be randomly assigned, so that half receive the new drug with the current and the other the new. The random assignment can be achieved by placing names of the hats of those in a high BMI group in a bin and mixing. The first 50% would be assigned to the new drug, and the remaining would be to the current medication. Please note, you can say after you've addressed one, the low, you would repeat the same process for the high BMI, and that would be acceptable. Here, I just wanted to be very detail-oriented. And then I said, after an appropriate time, cholesterol levels will be compared. Really important to say that what your response variable is, and that you're going to compare them at the end. My diagram, if I were to draw one, which is not required, would be I'd be blocking by volunteers, and here's what I'm blocking into: low BMI and high BMI. Then I randomly assign to group 1, which was the new medication, and group 2, which is the current current medication. So I want to break this down real quickly. We have a low BMI with new medication and a low BMI with the current medication. We have a high BMI, new medication, high BMI with the current medication. So I have 1, 2, 3, 4 treatment groups. I happen to have 2 explanatory variables. One was the blocking variable where I blocked by BMI. The other was the medication variable. So those are my 2 explanatory variables. My response variable is comparing treatment groups. I want to back up here because there's something I missed stressing. Randomly assign subjects within each block. This should be part of any design, blocking design. You always randomly assign within each block. You always randomly assign after the blocks. Cannot stress that enough, okay? So always make sure that you have that phrase if it's a blocking design. Randomly assign whatever it is within each block. The final question was, could this be carried out in a double-blind manner? And the answer is yes, it could be. And the reason it could be is no one needed to know, neither the data collector nor the controller needed to know what medication had been applied. So yes, this experiment can be carried out in a double-blind manner, and here's how you would do it. And so you answer the question, which is either yes or no. By the way, it's not Switzerland. You must give a yes or no answer. And then you need to tell how you're going to do it. And so in this case, label all the containers of the new drug A and the containers of the old drug B, so neither the subject nor the data collector knows which drug had been administered. Obviously, a controller would know at the end of the test which drug had been given so that a conclusion could be drawn. But basically, those collecting the data or administering the drug and those who are receiving the drug, the cholesterol drug, would not know. Okay?